and red chips also. Excited to say. Richard called up Justin last night. I talked to him on the phone. Oh yeah, we saw some of that red stuff, you know. He said we tried it in a Raman spectrograph system analysis. And he said we hit it with a laser. Now this stuff is behaving like thermite, folks. Again, I'm inviting scientific scrutiny of these red chips. I believe this is the last nail in the coffin, so to speak. Thanks. So, I don't hesitate at all. I invite laboratories and scientists around the world, not just the United States, to examine the red chips and the microspheres in the World Trade Center dust. Entertain all hypotheses, please. If you find some other explanation for these spheres, I would sure like to know about it. Yeah? Aluminum. By the way, the aluminum in this World Trade Center steel, we have had it analyzed. We have analyzed steel is small. Of course, also the potassium and the silicon are very small in this, and sulfur is very small. When you have steel with sulfur in it, it's brittle. This is not brittle. This stuff is well, structural steel. It's strong. Okay. Okay. Here's what I think it is. This is now my best hypothesis for this these red chips. It's I guess, an extremely fine mixing of ultrafine aluminum and iron oxide. This is a photograph enhanced from a paper that came out of Lawrence Livermore National Laboratory, in which they combine ultrafine aluminum and iron oxide in a gel, a solid gel. When you do this and touch it off, this is a photograph again from this website of this paper, it explodes. This form of thermite is explosive. It's not just an incendiary that melts, it explodes. And the reason is because the very fine particles of aluminum and iron oxide allow for a very rapid reaction. Gosh, it's so exciting as a scientist to see this coming together. Personally, I showed some of these data to a friend, and he said, wow, it's amazing how all these studies are linking together now, supporting the controlled demolition hypothesis, and now telling you what at least one of the explosives or cutter charges that was used. Remember that thermite cutter bursting out? That's what it looks like, that sort of thing. Okay, so anyway, but then he paused. He said, it's just exciting to see that come together. And then he paused and he said, it's exciting scientifically, but I am sad for my country. And he's right about that. And I have strong feelings about that too, and about the survivors and the family members, you know, that what they've gone through. Donna Marsh O'Connor will be speaking later, and Ellen Mariani, good friends of mine, Bob McIlvain, Bill Doyle, and so on. These people that have lost family, they want answers, you know. And I'm seeking those answers for them and for all those that perished and who are perishing, frankly, in these 9/11 wars, which I consider to be terrible wars. Now, let me point out for scientists, I hope I'm getting some interest built up among scientists, frankly. I mean, when scientists see things like this, they say, wow, I can study this. I know how to run a scanning electron microscope with EDS, no problem. You know, let me get some of that dust. I'll send it to you. Or actually, I'll have the finders send it to you. If we get enough requests, we're going to have to start collecting up some of the dust that's still in New York. And we can do that. You say, well, it might be contaminated, but we can compare with these samples that were acquired within 20 minutes of the collapse. Here's an unusual sphere. Jump in, scientists. Look at this one. Zinc, iron, sulfur, and oxygen. What an unusual situation. It would be interesting to explain that. Not too difficult in terms of thermite, by the way. Zinc nitrate is a good oxidizer. Here's another one. A barium-rich sphere. Look at the barium lines. These are X-ray lines. Very clearly barium present. Some of you may have read my paper. You'll know that barium nitrate is added to patented form of thermite called Thermite TH3, patented by the U.S. military. I'm not saying that's what this came from necessarily, the military form, but it's a well-known oxidizer, barium nitrate. Now, I'm just down to the last couple slides. Someone wrote to me recently, and I agreed with him. I thought he expressed it well. If only you could get one of your papers in a mainstream science journal, I think it could be a quantum leap that would do more good than 100 conferences. Okay? All right. My first paper in 2005 called for samples and photos. We're getting those. Called for an investigation. As it turns out, and Richard alluded to this too, we are conducting the investigation now. We may formalize that. Now, the result of this investigation, it's a scientific investigation at this stage, will be papers that should be publishable. I, with colleagues, have submitted 2 9/11 related papers to mainstream technical journals. The first one deals with Newton's third law. I just talked about that, as well as temperature considerations, which I talked about some today. There's, of course, a lot more detail in these papers. The second paper deals with the iron-rich microspheres. Working on a third paper, don't expect that too soon, on these red chips. Still a fair amount of work to do there, which again, I hope others will jump in. All of this, I think, is so important, and we're just nailing this down. One paper is currently, of these 2, is undergoing a rigorous peer review now in a major journal. The other paper, and this is my concluding slide, has already been accepted for publication. Thank you.